Okay, so I'm going to start by identifying the h value is pi over 4, theta minus h. So since h is positive, instead of starting at 0, I start at pi over 4. Next, I identify the period. For sine, the period is 2 pi over b, and in this problem, b is the invisible 1. So in this case, 2 pi over 1 is just 2 pi. So starting from pi over 4, I need to go 2 pi units to get to the end. Okay, and then I know that the halfway point is always important, as well as the 1/4 point and the 3/4 points. Okay, so here are my 5 important angles for this period. Next, I'll look at the y values. So the k value is 1, so the midline is at y equals 1. Okay, the a value is 3, so that means the maximum value, 1 plus 3, will be 4. And then the minimum value will be 1 minus 3 is negative 2. Okay, and then sine, if we think about our unit circle, sine starts at the medium y value, right? It's halfway up, halfway down. So start on the midline. Okay, so then we go up here. So this is the 1/4 point. So at the 1/4 point, sine the y value, this is the biggest y value on the whole circle. Okay. Then I rotate over here to the 1/2 point. And at 1/2, the y value is back in the middle. Okay, then down here at the 3/4, I'm at the lowest y value on the whole circle. Oops, sorry. And then finally, I rotate back to the end of the period, and I'm back on the medium or midline y. Okay, so here is one period. Okay, so I can repeat for one other period. I just subtract 2 pi from all these values. And I know that this period looks exactly like the other period. Okay, so domain for sine, I can see I can use every single input without any gaps. Range, the lowest y value I hit is -2, and I actually hit it, so I put the bracket. The highest y value is +4, and again bracket. Period, 2 pi over b was just 2 pi. Okay, amplitude is the absolute value of a, so absolute value of 3 is just 3. Phase shift is h, so pi over 4. And midline shift is k, so +1. Okay, so cosine. So h this time is 0, so that means that I can start at 0. And then my period is from the b value. So period for cosine is 2 pi over b. This becomes 2 pi over 3. So from 0, I go 2 pi over 3 units over. And then I'll do my other period at the same time. Okay, and then for each period, I know the important points are halfway, 1/4, and 3/4. Okay, so now for my y values, my k value is 1, so midline is 1, y equals 1. And then my a value is 2, so that means my maximum is 1 plus 2 or 3. And my minimum is 1 minus 2 or -1. Okay, so now cosine is the x values as we go around the unit circle. Okay, so we start over here, and so while y is in the middle, this is the biggest x value. This point is the biggest x value on the whole unit circle. So that means that I start at the maximum for cosine. Okay, so next I rotate to the 1/4 point. So this x value is right in the middle. So on the midline. Then I rotate over here. So this is the minimum x value. This is the furthest left point on the whole circle. Next I rotate back to the middle x's. And then finally back, the end is back where I started, and this is again the maximum x value. It's furthest to the right. Okay, so here's one period. And then I'll just copy that for a second period. All right, so the domain, I can use every input. Range, lowest value is -1, actually hit it. Highest value is 3. Period was 2 pi over 3. Amplitude is the absolute value of the a value. Phase shift is the h value. Midline shift is the k value. Okay, tangent. Okay, so remember tangent is sine over cosine. So wherever cosine is 0, tangent is dividing by 0, meaning it has vertical asymptotes. But first let's look at the h value. Here h is 0, so we do not need to shift. So tangent typically starts with a midline point at 0. Right? That's because at 0, y is 0, so 0 over x is 0. Okay, so we're going to center our period around 0. And for tangent, the period is pi over b. So for tangent, for this tangent, b is 1. Okay, so the period is pi. But the tangent graph we need to know is the midline point is halfway between the two asymptotes. So even though the period's pi, we want half on the left and half on the right. Okay, so from 0, I go left pi over 2 to get one asymptote. And I go right pi over 2 to get another asymptote. Okay, and then from the midline value of 0, I go pi over 2 to the right to get my other vertical asymptote. Right, so I want the distance between the vertical asymptotes to be pi, which it is. Okay, so besides these points, I know the 1/4 point is important and my 3/4 point. Right, so halfway between 0 and pi over 2 is pi over 4. So I've got my x values for this period. Now let's do the y values. The k value is -3. So there's what we can call the midline, even though it's not really a midline. And then the a value of 2 means I need to consider 2 units above -3 and 2 units below -3. Okay, so the general shape of tangent, we just want to remember the midline point is halfway between the asymptotes. The 1/4 point is a units below, so 2 units below -5, and then 2 units above the midline for the 1/4 point would be at -1. And again, I could just repeat for one other period. So pi over 2 is the end of this period, but it's the start of the next period. So pi over 2 plus pi would be 3 pi over 2. And again, the 1/2 point is important, the 1/4 point, and the 3/4 points. And then this period looks exactly the same as the previous one. Okay, so the domain, so it's not all real numbers now because there are vertical asymptotes. Okay, so I'll just pick a vertical asymptote. I know for sure pi over 2 is not allowed. Okay, and then after another pi units, I hit another asymptote. But if I go pi units in the other direction, there's another asymptote, or another pi past that. So we say plus pi k. This means every pi units away from pi over 2, there's a vertical asymptote. Range, within each period, we can see that the values go up and downwards forever. So I'll just use the r. Period, we already calculated as pi. Vertical stretch is the a value, so 2. Phase shift would be the h value, which we said was 0. And vertical shift, the k value, -3. Okay, cotangent. All right, so for cotangent, cotangent we want to remember is cosine over sine. So wherever sine is 0, cotangent is trying to divide by 0, meaning it has a vertical asymptote. Okay, so first we see if there's an h value. There is not, or h is 0. So that means we can start at 0. It doesn't get shifted. Okay, so what exactly happens at 0? Well, at angle 0, sine is 0 because sine is the y value, which is 0. So all sine would be 0, cotangent is dividing by 0, meaning there's a vertical asymptote here. Okay, and then next we can do the period. So here b is 4. The cotangent period is pi over b. So in this case, b is 4, so pi over 4. So after the start of the period, the end of the period occurs pi over 4 units later. Okay, and I'll go backwards as well to do one other period. Okay, so I know the important points for each period are the halfway point, the 1/4 point, and the 3/4 point. Okay, so there's all my angles. Now let's do the y values. So our midline is 2. And the a value is the invisible 1. So I need to go 1 unit above and 1 unit below. Okay, so for cotangent, I need to know the general shape. The midline point is halfway between the asymptotes. The 1/4 point is a units above. So starting at 2, I go up 1 unit to get to 3. And over here, I start at 2, I go down 1 unit to get to 1. And then this period looks exactly the same. All right, so domain would be, so not all real numbers again. We have some asymptotes. So I just pick any asymptote. I know 0 is not allowed. So you could say 0 plus, but then the asymptotes occur every pi over 4 units. Okay, range, all real numbers are allowed. period we calculated is pi over 4. Vertical stretch is the absolute value of A. So 1, or I guess you could say none if you want to say it's the same as the parent. Phase shift, H is 0, so 0 or none. Vertical shift is up 2. Okay, cosecant. So cosecant is the reciprocal of sine. Okay, so normally I would start my graph at 0, but here I have an h value of negative pi. So that means I'm going to shift my starting point pi units to the left. I'll just fill this out right now. Okay, so what exactly happens here? Well, when sine is 0, then at angle 0, sine is 0. So that means cosecant, which is the reciprocal of sine, would be 1 divided by 0, which is a vertical asymptote. But again, the vertical asymptote that used to be at 0 got shifted pi units to the left. Okay, so now I want to get the end of my period. So cosecant is based on sine, so it has the same period formula, which is 2 pi over b. In this problem, b is the invisible one. Okay, so to graph cosecant, I'm going to use I'm going to first graph its and then I'll work from there. All right, so in order to graph the sine function, I would first look at the h value. So here h is negative pi because it's theta minus h. So instead of starting at 0 like normal, I need to shift it and start at negative pi instead. Okay, so now the period is 2 pi over b for sine, and b in this case is the invisible one. Okay, so the period will be 2 pi. So starting at negative pi, I go for 2 pi units. So that would mean I end at positive 1 pi. Okay, I know the important values occur halfway through the period, 1/4 and 3/4. And now for the y values, the k value is negative 1. And then the important points occur half a unit above negative 1, so negative 0.5. And half a unit below negative 1, so negative 1.5. Okay, so sine, again, looking at my unit circle. So at the beginning of the unit circle, I'm at the middle y values. So at the beginning of my period, I'm on the midline. Then I go up to my maximum y value. Okay, then to my middle y value. Down to my lowest y value. And back up to my middle y value. Okay, so here is one period of the sine graph. And let me just repeat for one more period. So the end of this period was pi, but that's the start of the next period. So pi plus 2 pi means the next period ends at 3 pi. So again, I want my 1/2 point, my 1/4 point, and my 3/4 points. Okay, and then I know that each period looks the same, so I can just copy the pattern. Okay, so this dashed line represents cosine, or sorry, 0.5 sine of theta plus pi minus 1. Okay, so now how do we use this to get the graph that's actually asked for, which is cosecant? So for cosecant, we need to, I'll start with the vertical asymptotes. So wherever the sine graph is on the midline, that means that its reciprocal will have a vertical asymptote. Okay, and then I know that the vertex of cosecant curves touch the maximums and minimums of the sine function, and then they just curve up, approaching the asymptotes on either side. Or down. All right, so the domain be, so I can start at 0, and then every pi units on either side, I have an asymptote. So everything is allowed except for 0 plus pi k, so I can ignore the 0 part. Range, so I go downward forever over here. I go up to and include negative 1.5. But then I jump to negative 0.5 and then go upward forever. Period. So remember, the period is not just one distance between the asymptotes, because the next section is different. So you have to include both parts in your period. So the period is 2 pi. Vertical stretch is your a value. Phase shift is your h value. Vertical shift. Secant is the reciprocal of cosine. So in order to graph this function, I will consider first cosine of 2 times the quantity theta minus pi over 2. Okay. So let's see, we have an h value of pi over 2, positive pi over 2. So instead of starting at 0, I will start my period at pi over 2. Okay, and then for cosine, the period is 2 pi over b. In this case, b is 2, so pi. So from pi over 2, I go pi additional units to get to the end. So pi over 2 plus pi would be 3 pi over 2. And then I know that the halfway point is important, as well as the 1/4 point and the 3/4 point. Okay, and now for my y values, the k value is plus 0, so the midline is just y equals 0. And then the a value is 1. All right, so for cosine, the x values, at the beginning of the period, at the start, I'm at the maximum. So at the beginning of the period, I'm at the maximum. Then I go to the midline, over to the minimum x value, down to the, back to the middle x values, and then over here to the maximum x values. Okay, so here is one period of cosine. And then I can repeat for one additional period over here. So pi units before pi over 2 minus pi would be negative pi over 2. So the halfway point is 0, 1/4 point is negative pi over 4, 1/4 point is pi over 4. Okay, and again, each period looks the same, so I can just copy the pattern. Okay, so I've got cosine graphed. Now for secant, the reciprocal, I just base it off this graph. So everywhere cosine hits the midline, secant will have a vertical asymptote. Okay, and then I just draw alternating curves that touch the maximums and minimums of the cosine. Okay, so the domain, what values are allowed for secant? Well, let's see. So one asymptote is at pi over 4. So all real numbers except, and then additional asymptotes happen every pi over 2 units after that. The range, I can go downward forever. The highest value I hit is -1. Then I jump to +1 and go upward forever from there. Period, I calculated for this problem is pi. Vertical stretch would be your a value. So 1, or I guess you could say none if you want to compare it to the parent function. Phase shift, h value is pi over 2. And vertical shift, the k value is 0.